Okay, Dijkstars. Dijkstras algorithm. So we have the terms fringe vertices. Karma. So we have these fringe vertices. These are nothing but the set of vertices which are adjacent. Set of vertices adjacent to vertices in the tree, and those are referred to as fringe vertices. Okay. Okay, let's discuss the problem. Okay with the problem? Let's move on to the problem. I can.
Yes, ma'am.
Yeah. Because we use this term in the algorithm, fringe. So you should know that. Okay. The problem will take up. A, B, C, D, E, seven. Note down this. 3, 2, 4, 5, 4, and 6. This is the graph given. We have to find shortest path from A to all other vertices. That is Dijkstra's algorithm, from source A to all other vertices. So what is the distance from A to B? The shortest path from A to B. What is the shortest path from A to C? Shortest path from A to D and shortest path from A to E. That is the thing what you have to find, or that's what we will find in Dijkstra's algorithm. Let's start. So we have three vertices. You will have your second AA scheduled from 28th onwards this month. So before that, we have to complete module 3 and start with module 4. Okay, we'll do that. So from A, we'll start like this. Distance 0. None of the vertices are selected and the distance is 0. Which are the remaining vertex we have and what's the cost to reach those? As we had done in one more problem. What was that problem? Did we write like this in any of the problem? That from A, what are the vertices? Yes, sorry. Which algorithm?
Knapsack.
Knapsack. Is it knapsack?
Prims, ma'am.
Yes, Prims. Okay. So we have to reach B. Let's check what are the direct paths available. Knapsack is purely a problem with bag, profits, weights. This is with respect to graph. So graph problems, whatever we have discussed is prims and crystals. Now we are doing with Dijkstars. Don't get confused because you all are new to this topic and you are all new to the subject also. Be calm, think, and then you will not get when you write your internal or when you write your external, you should not get confused. Okay. So direct path to B through A with a cost of 3, we have it, direct path. Then which C can we reach? Can we reach C directly from A? Can we reach?
No, ma'am.
No.
No,
So
ma'am.
what we have to write? So
Infinity.
C cannot reach, so we'll write infinity. What about D? We can reach and it is through A only and the distance is 7. And we can also, can we reach E? No, because it is out of reach. It's not, we don't have a direct path.
No,
We'll
ma'am.
start like this. Yes, we'll start like this. Okay, among this, which is the, it will be similar to prims, but here we have to find the shortest path from A to every other vertices. There we just check whether it is reachable. With a minimum spanning tree we'll consider, but here it is a shortest path from A to all other vertices. Okay, so a little bit of difference is there. So now among this, which is the smallest path, we can reach B with a cost of 3. This is the smallest, shortest path. So we will highlight that in the graph. See, I will not be interested in writing a very neat diagram. I will not be expecting a very neat diagram from you, but diagram should be there. The illustration should be there. I don't want you to, that means that I don't want you to take pencil, scale and then draw it. Rough figure saku. Okay. So that you will illustrate what is happening. That's how you should. Okay, but you should not take compass, draw this circle, then take scale, draw this line and waste time. So what is that we will take now? We will have, but neatness should be maintained. Rough figure is enough. B of a comma 3. This one we are selecting now. So we have that in as a part of three vertices B of a comma 3. Now what we do is from B, A it's already done. A to B we have selected as the shortest path. Okay, this is the shortest path now. From B we will check which are the paths available. To reach C, is it possible to reach C through B? Yes, it is possible.
Yes.
Yeah, what's the path? What's the length? 4.
So,
Together with this length, we should also consider the already selected path, shortest path A to B. This length also we should add. So we will say to reach B, we have already selected path 3. This value we'll add plus the distance from B to C, which is 4. That's the difference in prims and crystals. Don't get confused. This is shortest path from a source to all other vertices. There we are just finding minimum spanning tree. Okay. So to reach C from B, it is with a cost of 4, but this path is already selected. So we will say 3 plus 4, which is 7. Now D. Okay. D, to reach D from B with a path of 2. We already have a path 7, but we are trying to, we have already selected this as the shortest path. So from here, we should try to check the distance to reach D from B. So to reach D, we have this, you should write down 3 plus from B to D, the distance is 2. Okay. Then E, is it possible to reach? Can we reach E from B? We cannot reach. Now, right now we cannot reach. So we will just take it as infinity. Here we had selected this, isn't it? A to B. So from B, we got C with a distance of 7. Here also when we compared, this was smallest. So we have taken this. And we also have, if this was larger, we wouldn't have considered. So this, and we have one more path which we selected just now. A, B, C, D, E, 3. This we have selected now. And among this, which is the shortest? Which is the shortest among this?
D.
Yes. So we will take this. Okay. So B to D, we have taken the path. We can reach D from A directly, but the cost is 7. But if we go through B, the cost is 5. In this case, which one we should select? The shortest path, because Dijkstra's algorithm works like that only. It will try to find the shortest path between the source and all other vertices. So we have selected this path, 5. Next, So we have this D of B comma 5 select. So from D we can reach C, right? From D we can reach C also. But look into the distance, whatever is required. Check the distance. From D it's possible to reach C. But check the
It's already reached.
Yes, because the path is 3 plus 2 5, 5 plus 5 10. Whereas if we go through B, the path is 7. So we have to retain this shortest path, B comma 7. This only I am retaining. It's possible to go to C with the help of D, but the cost will be 10. Hence what do? We just select the earlier path itself, 7. Now, which is the other node? E. Yes, we can reach E, isn't it? We can reach E with the help of D. So what's the path? 5 plus 4. So reaching 5, this distance, plus 4, D to E. Okay. So we have selected. I write on here only. Among this, which is the shortest path? So which is the shortest here? B comma 7 and D of D comma 9. This only is the shortest. This only is the shortest. Hence we will consider this only. So we have this selected. Let me write down. B, C, E. So we selected this first, this next. Now we are moving to C of B comma 7, which is this. Okay. Now we are left out it only. So we selected C of B comma 7. Now we are left out with only one, D comma 9 over D comma 9, which is 9 here. Okay. Or else we can check this also. If at all if this is checked, 7 plus 6 13, whereas this is 9, because we know that these two are already shortest path. So from D, when we check, D to E is the shortest path. So D of E of D comma 9. So that is the last edge which is selected. So this is the problem solved. Then you have to write this from A to B. The path, the length is, to reach A to B, the length is 3. From A to B to D, the length is 5. Okay, A to D, the length is 5. Length from A to D. This is the path. Length is 5 and the length from A to C takes the path A, B, C. A, B, C, and the length is 7, isn't it? A, B, C. A, B, C, the length is 7. And from A to E, we have A to B, then D, then E, and the length is 9. This is path. From A to B, the path is directly A to B and the length is 3. From A to reach D, we reached D with the help of B, isn't it? With the help of B we reached. Hence we have ABD path, which is with the length of 5. Then to reach C, we went through B, so ABD. Here you'll get which was the source for this. See, to reach B, it was A. To reach D, we went through B. That's what we have written. To reach C also we went through B. And to reach E, we went through D. When we go to D, we'll come to know B also was involved. So we say E, D, B, A as a path. A, B, D. And the length is 9. And you have to write this in the problem. Okay? Understood?
Yes, ma'am.
Yes, ma'am.
Yes,
Yeah.
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
Now I'll just give. Will you note? Have you noted this, or you will be writing? You will write down.
Yes, ma'am.
Yeah. I'll give you 5 minutes. You note down this. Then I'll give you one more graph for which you will find the answer.